In today's video, we'll be talking about water supply and let's start with it. Imagine this is your home and you have a road going on. So, this is your road, and this is the water line that is laid under the road, which is your municipal water supply. Okay, so from this road, we'll take connection from it, which is called as the ferrule connection. Ferrule is, it's like a fixture that is made of copper, which is laid onto the municipal water supply lines, and it helps in taking water to your building. Okay, so you have your ferrule connection, and you take the water pipes, and these are known as service lines. In this service line, we have two things. Okay, so one is your water meter, which measures the amount of water that you are consuming and everything, and it also has an opening or closing, which is a control valve, which lets out the flow of water through your building. Okay, so you have the service line, and then it is laid out as a pipe on the building, and it is supplying to the different appliances, different spaces like your kitchen, bathroom, every other space. So this vertical pipe that is laid across the wall, that is called as raising main. Okay, so you have service line that is connected to the main water pipe. This is your municipality water line. So service line is connected to that. And from there, if the pipe is laid across the wall vertically, it's called as rising main. And there are two types of system basically. One is this, where the like water has a pressure, right? So if the pressure is high, it can be directly supplied to different spaces of the building, usually in your single storied buildings, single storied residences usually. If the pressure of water is high and if municipal water is supplied 24/7, then you can use this method, where the water from the municipality line is taken and it is supplied through all parts of the building. Then that means direct supply. It's called as direct supply, or it is even called as the upfeed system. Upfeed system or upward system, because the water is basically moving upwards, right? Okay, but sometimes, most often, we do not use the upfeed system or the direct supply because we don't have that great pressure, and neither is our municipality supplying it 24/7. So a lot of residences and a lot of buildings in India use the second system, which is your indirect supply. And again, imagine this is your building. This is, imagine that's your overhead tank, and again you have your road. Now everything the same as before. You have your municipality water, And from here, you have your service line. Okay, so everything is similar. Service line, you also have your water meter and controlling valve, everything. But instead of directly supplying to the building, it is first stored in a sump. So this is first stored in a sump. And sump, it is basically an underground storage tank, and it's also called as the suction tank, while people generally call it a sump. So first the water is filled into the sump, and from the sump you use a motor. Okay, so you use a motor or a pressure booster pump, and then you supply it to the overhead tank. Then from the overhead tank, the water is supplied to all other parts of the building and using gravity pressure. Okay, so it's applied everywhere else, and this uses gravity. So this system is your indirect supply of water or downfeed system. Okay, sometimes there is a combination where they supply directly to the kitchen alone, and all the other places use the overhead water tank. So that is your combined system. So mostly they are not used. Maybe in some residences they can be used. And now let's talk about other types of tanks that are there. So you have your overhead tank or header storage system. So this is basically what we talked about here, where the water is supplied to the sump, and from where it is pumped to the overhead tank using a motor pump or a booster pump, and from there using gravity pressure it is supplied to other parts of the building. Okay, so this is your overhead or header storage system. Then you have something called as the brake pressure tank system. Now imagine a multi-story building with multiple levels. I'm just drawing few here, and this has an overhead tank. Now, when the water flows from the top to the bottom, right, it has to supply to each floor. But most often, what happens is the pressure that is built up on the lower floors is high because of gravity. Okay, so here the pressure would be, and they call this as the hydrostatic pressure. Okay, And when the water flows from a multi-story building towards the end, it can flow at a very high pressure at a high speed, and that could lead to your pipes bursting. Okay, your pipes can burst. So to reduce this pressure, they have tanks that are attached to different zone. Okay, so what they do is they divide the building into different zones, and each zone can be up to 5 to 8 stories, and each zone has one break pressure tank. Okay, so let us imagine now this is one tank here, and we have another tank here. Okay, so when the water flows from the overhead tank towards the brake pressure tank 1, let's rename this as BPT1 and BPT2. So your BPT1 reduces the pressure of it, uh, regulates the pressure, maintains it maintains the pressure of it, and lets it pass through the pipe again. Lets it pass through the pipe again, and the BPT2 receives the water which is at a high pressure again, regulates the pressure, reduces the pressure again, lets it flows to the bottom flows. Okay, and then it is supplied. So this is your brake pressure tank. So brake pressure tank basically breaks the pressure of the water in the pipe by introducing tanks in the middle in different zones. And these BPT tanks should have a capacity for maintaining water up to at least 15 to 20 minutes. Okay, so this should be their capacity. Now let's talk about another system, which is hydro pneumatic system. This is again similar to brake pressure system in terms of how it is divided into zones. So again, your building is divided into zones of it is either 7-story or 20 meters height, whichever lesser is considered. Okay, so again, what happens is your water, it is first stored in your sump, and from this sump it is pumped into the pressure tank or hydropneumatic tank, whatever you call it. And this pressure tank has an air cushion in it. So it has an air cushion. So what does this tank do is it maintains the water at a steady pressure. Okay, so it gives pressure to the water and maintains it at that pressure, and then later it is directly pumped throughout the building. And here you do not need a overhead tank for this, so no need for overhead tank. And they also use something called as non-return valve. I'll talk about valves later, and I'll also remind that they are used in the hydropneumatic system, but just remember it now. Non-return valve and pressure relief valves. So these two are used in the hydropneumatic system. And now that we talked about the different types of water tanks and system, let's talk about the consumption of water per day per head in different spaces. So water consumed in liters per day per head. Let's talk with residences first. So in residences, we use 135 liters per day per head, and it is the same for boarding schools as well. Schools also uses 135. Then you have offices which uses 45 liters, and your day schools, they also use 45 liters. Then we have theaters, cinemas, all those places. They use 15 liters per day per head. And then we have restaurants which uses 70 liters. And then we have hospitals. So hospitals has two categories. One, if it is under 300, sorry, 100 beds, then it uses 340 liters. If it's more than 100 beds, it uses 455 liters. This is the water consumption of different types of building per liter, sorry, in liters per day per head. Okay, now let's move on to other topics, which is hot water. So hot water supply can happen two ways. One is through water heater, which is which is generally used throughout India and all other places. But there is also a centralized water heater system, which is very common to how the central AC system works, but it's not used a lot. And in water heaters, you have three types, which is first is your instant geyser, which you can turn on like in 5 minutes. Your water is heated, and then you can go take a bath. So that is your instant geyser. Then you have storage type water heater, which takes more time compared to the instant geyser, and it basically has a tank like fixture on which the water is stored. It is heated and then it is applied to your taps and stuff. You have solar water heater. Solar water heater basically uses the radiation of sun to heat water, and this should be placed at the top level of the building, but below the overhead tank, so that the water can be supplied to the heater without sorry, with using gravity. So it should be placed at topmost level, but below overhead tank, so the water can be supplied via gravity. And um, the glazed surface of the collector should face south. so that it receives maximum sun and heats up the water more quickly. So mixing taps is basically you'll have one outlet, you'll have one outlet, but you'll have two taps, like one for the hot and one for the cold, right? So, but the pressure of water on both the cold and the hot should be equal. Okay, so it should have equal pressure to be maintained on both the hot and cold taps. Then, if you see materials, you can use copper is widely used. You can also use galvanized steel, and lead should be avoided because this can dissolve rapidly due to the hot temperature, and the temperature, like it's hot water, right? So the temperature desirably maximum should be at 60 degrees Celsius. Okay, now let's move on to sanitation. So we have drainage system, and what is, if you ask, like what is the primary aim of a drainage system, then it is to quickly and safely collect and dispose waste from the building. So that is the primary aim of a drainage system. And if we see, earlier there used to be a drainage type of system called as the Conservancy lane system, or it's also called as the dry system, where your the garbage, your waste and everything, along with your night soil, which is your human excreta, right? So it is collected manually every single night. So it used to be collected manually, and it was not, it was not as, it was a safety hazard. It was not hygienic, and it caused a lot of problems. So the legislation banned the system, and now we have something called as the water carriage system, where both your soil, waste soils, and the wastewater is taken through a single channel, and it is, it's taken up to the treatment plant, after which it is treated, and then it's let out into the environment. So the system that we now use, it's called as water carriage system. Okay, and now let's talk about the different drainage or sewage disposal system that we use. So we have inspection chamber or manhole, and this is provided at every junction, and at an interval of 30 meter if it is in a straight line, and if it's a long line, then it is placed at an 10 interval of 30 meters. Okay, and if you see the manhole, it's a masonry wall. It's a masonry pit. It's not a wall, right? So, and the top, right? The top is covered with cast iron to, prevent the release of foul gases. And if you see inside the pit, it has a steep slope towards the center, which has the open channel. So, this is your channel, and this is your steep slope. So, this is your manhole or inspection chamber. Then we have septic tank. This is covered with a removable cement slab. Imagine this is your inlet pipe, and this is your outlet pipe. So this is your inlet, this is your outlet. Okay, now this is your inlet and it's your outlet, and the waste inside the septic tank is basically divided into two parts. One is the heavy matters are settled on the bottom, right? The heavy matters are settled or sedimented to the bottom, and these are called as sludge. And the lighter matter, like your oil, grease, and stuff, they float on the top, right? They are called as scum. And whenever the water is let in order to not disturb the scum and the sludge, you usually have a vertical partition. This is your vertical partition, so that it hits it, the speed is reduced, the velocity is reduced, and then it does not disturb the sludge and the scum. This vertical partition is called as your baffle wall. So this is your baffle wall, which is your vertical partition. And septic tank, the reaction that takes place inside it is here an anaerobic reaction, which means it takes place in absence of oxygen. Which means the septic tank is airtight, should be watertight, and kept away from light. Okay, so this is septic tank, and septic tank is a treatment method. Then you have something called a cesspool. Cesspool is a storage. It's nothing but a storage pit. Okay, so just a storage pit, and the treated, partially treated water or your effluent, it can be let out into the soak away. And I'll talk about soak away in a bit. But let's move on to the other type of tanks. Then you have Aqua Privy. So Aqua Privy sits directly below your WC, which is your water closet, right? So if you see it in a drawing, now imagine this is your toilet, and it's a commode, and someone is pooping or urinating or whatever. Now, this Aqua Privy tank, right? Septic tank. It's a type of septic tank basically. It is situated right below it. So whatever that you're doing, it directly drops to the Aqua Privy septic tank. Okay, and this too has again your this is your inlet. It also has your outlet here, and I'll talk about the outlet and everything in a minute. Now, your human excreta or your soil directly drops to the pit. Toilet or WC sits directly on top of the septic tank. Okay, again, you have your scum. This is your sludge. And there used to be two versions. In the older version, there was no soak away or soak pit. The newer version has sometimes has two chambers with a baffle wall, which separates the human excreta and other watery materials, and it also has a soak pit. And before talking about what is a soak pit, since I told you this is Aqua Privy is nothing but a variation of septic tank, this is also again an anaerobic reaction. And whatever this outlet pipe, it leads to your soak pit. Now, what is a soak pit? Soak pit can also be called as soak away or leach pit. Okay, so soak pit can also be called as soak away or leach pit. And this is basically a rectangular or a cylindrical pit which is covered with rubble, gravel, and coarse stones, all those kind of material. Okay, so this is a cylindrical pit or a rectangular pit which is filled with gravel, coarse stones, rubble, etc. So, what does happen is when they release the effluent, now effluent means partially treated water. So, when they release the effluent through the soak pit, it passes through this like gravel, coarse stone, rubble machine. It passes through all this filtration, and then it is slowly let to percolate to the surrounding soil. So that is the main purpose of your soak pit. So here the effluent percolates into the surrounding soil. So this was our three types of tanks that we saw. We saw septic tank. We also saw aqua privy. Now let's talk about different types of plumbing or pipes that are used for drainage. Okay, so you have stack pipe, So stack pipe is a one vertical main which carries everything like your soil or waste, water, or your vent pipe, everything. Vent pipe is your ventilation pipe so that it lets out the foul gases to the atmosphere. Okay, and I'll talk about that later. But vertical stack pipe is a vertical main for soil waste, water waste, and the vent. Okay, so this is for soil, water, and vent. It's a one vertical main. Then you have a soil pipe which is for soils. Soils means human excreta alone. So human excreta flows through it, and it's usually of 100 in dia. Then you have wastewater pipe, which allows only water in it, and this is usually 75 in dia. Then we have something called as branching pipes. These branching pipes, these connect the fixtures like your wash basin or your cupboard or your kitchen sink and everything. So this connects the fixtures with the stack, and that is your branching pipes. Then you have vent or an anti-siphonage pipe. This is important now. So now, before I explain the pipe, there are a few things that you need to clear up to understand this better. Usually, most of the fixtures, like a lot of your wash basin, sink, or anything, it is connected via a trap, and the traps are of various types, and I'll talk about them later. But for now, just understand that. Okay, so this is a P trap, and imagine this is connected to your commode. Okay, and this is filled with water all the time. Usually has water filled in it. This water that is always present is called water seal. And the main function of water seal is to lock the foul smells away from the building. Okay, so even the foul smell tries to come into the building via the pipelines, the water seal captures it and keeps it away. So this does not let foul smell within the building. And this is your trap, and there are various type of trap here. Here I have shown the P trap. Now, um, due to siphon reaction, so siphon reaction is the flow of water from usually a higher position to the lower position because of gravity. Or for an example, if you if you see a straw that is filled with liquid, and if you keep a finger to one end and remove the straw, the water would still be intact inside it, and when you take the finger away, it will flow out. So that is another siphon reaction example. So due to the siphon reaction, the water seal or the water that is present inside the trap can get sucked away, and to prevent that from happening, you use the vent pipe or the anti-siphonage pipe. So anti-siphonage pipe makes sure the water seal is intact, and it also lets out the foul smell towards the atmosphere so that it doesn't come back. Okay, so these two main function are part of the vent or anti-siphonage pipe. A vent is basically ventilation, so it's also called as the ventilation pipe. It's usually 50 mm in dia, and if you see the section, and if this is your floor, this is your commode or whatever, it's usually connected at an angle, right? And this angle is usually 45 degrees. So anti-siphonage pipes connect at a 45 degrees angle, and it's usually 50 mm in diameter. Okay, so this is your anti-siphonage pipe. It goes above the roof level, and it has a cover mesh or something. It's called as cowl, basically. Cowl or cowl, I don't know how to pronounce that. COWL. And it looks like this with little bit of holes in it, and this is your pipe. So it acts like a cover so that it keeps rodents or insects from getting into the pipe, and it also lets out the foul smell outside. So this is how the ventilation takes place. Then you have rainwater pipe, and as the name suggests, it's the pipe through which the rainwater that is collected in the terrace is flown down. So rainwater pipe is that, and its diameter is 50 mm. And now that we talked about different pipes, let's talk about the different plumbing systems that are used in drainage collection. Okay, so there are basically four systems. You have one pipe system. So in one pipe system, you use one pipe for the soil waste, the water waste from all appliances, and one pipe provides ventilation for everything, like all fixtures, even your wash basin, everything is provided ventilation. And this is more feasible comparative to other system. Then you have single stack system. In this, only one pipe collects the soil waste, water waste, everything, and this also acts as the ventilation pipe. So if you see, if this is your single stack system, it extends above the roof level, and you have the cowl on top, basically that acts as the ventilation pipe as well. Then you have a single stack partially ventilator system. So in this, it's very similar to single stack. So this also has only one pipe for your soil and wastewater, but it has a partially ventilated system, which means only some of the fixture is ventilated. Maybe your commode alone is ventilated, but your wash basin and your sink, kitchen sink, and all other appliances are not ventilated. So it's partially ventilated. So this again has two pipes in total, just like your one pipe system. One pipe system also has two pipe in total. Then you have something called as the two pipe or double stack system. Okay, so It's two pipe. In two pipe or double stack system, you use two separate pipes. So one pipe for the soil waste, one pipe for the water waste, and each is ventilated separately. So this is ventilated separately, and this is ventilated separately. So it means it has four pipes in total. So these are the four plumbing systems. Now let's move on with sanitary appliances. So if your appliance, collects just a wastewater, drainage water and all that, it's called waste appliance. And if it collects human excreta and other soil wastage, then it's called as soil appliance. Now let's look into different sanitary appliances, and we'll start with wash basins. So there are two types. One is flat back and the other is angle back. And yes, as you can see, flat back is placed against the wall, and this is placed in a corner. And this hole that you see here is your overflow hole, which means the when the sink is overflowed with water, it flows via that overflow hole and it is taken down the drain. The top rim of the wash basin should be around, let us say, 0.75 to zero point 0.8 meters from the floor. And whenever possible, imagine this is your sink. Whenever possible, the plumbing should be taken through the wall and not through the floor. Not through the floor. This is not advisable. This is advisable. And this is wash basin. Then we have sink. So sinks, there are three types. You have Belfast type, ordinary, and stainless steel. In Belfast type, you have the overflow hole. You also have drain boards. Drain boards are what, something that you have on the sink, on the side of the sink, where you wash your utensils and place on it so that the water drains back into the sink. So we have drain boards on either side. In ordinary sink, you do not have an overflow hole and you do not have a drain board. In stainless steel, you do not have a overflow hole, and sometimes you have at least one drain board. At least most of the times. Sometimes it's still not present, but sometimes it is there. Then we have different types of taps. So taps are also called as faucets or spigot or cocks. And there are different types of taps depending upon where they are mounted, and sometimes even depending upon the shape. So if it is fixed to the wall, then it's called bib tap. If it's mounted on the wash basin or sink, basically mounted on any fixture, then it's called pillar tap. And this is called as swan neck tap because of the shape of it. And since this is most predominantly used in sinks, it's also called as your sink tap. And taps are nothing but a valve that regulates the flow of water, and there are different types of taps. Now let's move on to showers. So there are also again different types of shower. I'm just gonna mention one thing. The shower head should be 2 meters from the floor. And you also have different types of bath tubs as well. So the bathtubs, the depth should be 40 to 45 centimeter, and length can range from 165 to 180 centimeter. I'm just mentioning the important things that is necessary for you to remember. Then we have different types of urinals. These three are for the men, while this is for the women. This is your bowl type urinal. This is called as slab type, or it's also called as a trough. This is your stall type, and this is squatting plate type. Squatting plate type. So, as the name suggests, they are very distinctive because of the types. Bowl type is your simple urinal, and slab type of trough type is basically all the urine is collected here and then is taken to the drain. And stalls are basically you have partitions between each urinal, and the clear distance between the each urinal should be a minimum of 60 centimeter, and the top of the bowl to the floor should be 60 centimeter. Okay, and now more than 7 urinals are to be connected to one outlet. So this is the different types of urinals that are there. Now let's talk about different water closet, which is our toilets. So there are three types again. So you have Indian, which is our squatting pan type. Then you have Western, where you sit on it, and then Anglo Indian, which is a mixture of both the Indian and the Western. So in Indian, we also know it has the footrest, it has the squatting pan. This is of different types. So you have long pan, Orissa, rural, and integrated. And they vary in the size and the shape of it. Then we have Western. So Western, uh, it's basically where you sit on it and you do your business. But it can be categorized into two types depending upon the flushing mechanism. So depending upon the flushing, It can be categorized into two types. One is wash out or wash down closet, and the other is siphonic closet. So wash down or wash out closet is, basically gravity is used to pull out the solid, which means your human excreta and stuff. So, and here siphonic action is used. Washout is a lot, it uses a lot less water. This uses more water. This is a lot cheaper, plus it's also a lot older. This is costlier, of course, and it's also newer. So, and it's expensive. And this makes classic blop sound as it flushes, and this is almost noiseless, so it's a lot quieter. And this smells a lot, and this has a deep water seal, and that means it has like better order control. Better order control. So these are the two types. So in washout, gravity is used to pull out the solid in the trap. In siphonic closet, a large amount of water is, enters the trap when you are flushing the toilet, and then it creates the siphonic action and pulls out the solid in the trap. So these are the two types. And Anglo-Indian is a mixture of both the Indian and Western, where basically you can sit on it, also squat on it. And this is an Anglo-Indian toilet. So flushing cistern is basically the device or the tank which discharges water when you're flushing. So this is the tank that discharges water for flushing. Again, it is of two types. One is bell type and the other is disc type. Bell type is, again, it's the older version. It's also noisier, and this uses siphon action, while your disc type is newer. It's also quieter, and in this the water flows not because of the siphon action, but because the disc is lifted, and when the disc is placed again on top of it, the water flow stops. So water flow only when the disc is lifted. There are also other types of flushing system called as the flushing trough. Both of which are used in a lot of public spaces. And as the name suggests, automatic flushing system is it does it automatically. And flushing trough is how we saw the slab urinal, so it's something like that. Then let's move ahead, and we have our flushing valves or cocks. So flushing valves or cocks are the one that connects the fixture, the like your urinal or your water closet, with the overhead tank. So the flushing happens due to gravity. Slop Sink, or Sluice Sink. So this is used in hospitals and also uses a siphonic action. The patient's vomit and other solid matters are flushed down this sluice sink basically. And let's move on to bidets. It's basically an ablution fitting where a person sits on it and cleans themselves their private part after excreting. So that's bidet for you. Then let's move on to traps. And imagine this is a P-shaped trap. I'll talk about the shapes later. But there are different parts of a trap basically. So this is your lower dip. This is your upper dip. And of course you have your water seal. So this is your water seal. Then this lowest portion which goes out, it's called as crown wear, and this is called as top wear. And this curve, no, that is called as your crown. And usually the water seal is 35 to 100 in length or depth. Okay. So there are a lot of different types of traps, and we'll look at it one by one. So this is P trap. You can see it in the shape P. Again, that's your water seal. Then this is Q trap in the shape of Q, and we have S trap. S trap is most not generally used because it tends to have a lot of siphonic action and it tends to break its water seal. So it's mostly avoided, but it's still used some places. And all these three tabs, they're used in your water closet. Okay. Then this is our bottle trap. So a bottle trap is usually, it's shaped like a bottle and it's usually used in your wash basin, also in drinking water fountain, all those places. This is Nahani trap, or it's also called as the floor trap. You would have seen it in your bathroom floor. So it's usually used in your bathroom where all the water from you bathing or sometimes the excess water from the wash basin or the water closet, everything flown through the honey trap. Then we have gully trap. So gully trap has this uh, mesh or grating followed by a chamber, and then the trap part of it. So the trap part of it can be of different shapes like P, Q, or S, and this is mostly used in outdoor spaces and pavements, all those kind of areas. So this is we have intercepting trap. It is also called as the sewer trap. So this is basically the trap that connects your home drainage to the municipal drainage, and it also stops the foul smell and the sewer from getting into your home or your building with the municipal sewer. I'll just draw a quick section here to show it. So imagine this is how the channel is flowing. This is your inlet, and this is takes to the sewer, municipal sewer. And this pipe, one of the pipe, the topmost most usually. So this one, it is covered with a plug. Then you have a grease trap. Grease trap are generally used in restaurants or hostels, hotels, those kind of places. You can see it looks like a mechanical box, and it is very similar to how a septic tank, the mechanism works. So if you see within the grease trap, so this is basically a rectangular box. You have your inlet, you have your outlet, you also have the partition, which is called as the baffle wall here, and the solids, you know, the solids settle on the bottom, while the oil and other grease and all the other flows float on the top. So this is your grease trap. Then you have something called as stilt or residual trap, which is basically used in courtyards or pavements to collect the stilt and everything, trap it basically. Then there is stable trap, which is used in stables. So these are the different kinds of traps. Now let's talk about stormwater drainage. So basically there are two systems, but before I talk about the system, let me talk about something called as the French drain. So imagine this is your topmost soil, your sand and every grass or whatever that's there. Then you have a layer of soil beneath it, and below that you have gravels. So you place gravels, and in the middle you place your pipe, and beneath it again you have gravels. And this pipe is not your usual pipe. It is has perforations in it, which means it has holes in it. So what happens when the storm water is flowing through the pipe, and this is your perforated pipe, and it is of 100 mm dia, right? So when the storm water is flowing through it, and the storm water is flowing through it, due to the perforation, it passes through the gravel. It passes through the gravel and slowly, it percolates into the surrounding soil. And this is important to maintain your groundwater table. So this is important to maintain your groundwater table, and this is slowly percolates into soil. Now, about the different types of stormwater drainage system. So there are two types. One is the combined sewer system, and the other is separated sewer system. Right? Okay. In combined sewer system, both your drainage from the home and other buildings plus your stormwater from the rain both pass through one pipe, one single pipe, right? And in case of in case of heavy rains, the overflow from this pipe is directly let into the water bodies. The overflow is into the water body. And this overflow is of obviously it's not treated, so it's not treated water, and it's directly let into the water bodies. In separated sewer system, your drainage from the building is connected to one pipe, and it is taken up to the treatment plant where it is treated, and after that it's let into the environment. Whereas your stormwater has a separate pipe from where it's let into the water bodies. So these are the two types of um, stormwater drainage system. Now I'll just mention few materials and the type of pipes and where it is used. So cast iron pipes are generally used for city water mains. Then you have copper pipes. I've talked about this already. It's used in your water heater. So heater. And then you have lead. This is mostly used in your wastewater pipes. So wastewater pipes or discharge pipes. Then you have asbestos cement. These pipes are usually used in your rising main and other distribution pipes. Okay, now let's talk about different types of fittings that are used to connect pipes. This is called as coupling or coupler or socket. Okay, and this is basically something that is used to connect two pipes. But here's the deal: you see this threading that's running along the inside of the pipe, right? So if it is done inside, it's called the female part, and here you can see it's outside, right? So if it is outside, it's the male part or male thread. So coupling coupler or socket is a female part which connects two pipes. So you have like one pipe here and one pipe here. And if it is a male part that is connecting two pipes, then it is called as nipple. So this is again connects two pipes, but since it has male part, this is called as nipple. If it's connecting two pipes of different sizes, then it is called reducer. So here you have one pipe, and here this is a much bigger pipe. Then this is called gooseneck. So gooseneck is this flexible pipe that can bend in any way, and it's usually used in wash basin, sinks, and other places. So this is a lot flexible, used in wash basins. Then we have bend. So bend and also elbows. They are used when you want to give a different direction to the pipes. So provide change of directions. And this is 22.5-degree turn, and that is called as bend. If it is 45 degrees or 90 degrees turn, then it's called elbow. Like here, this is a 45 degrees turn, so it's called a 45-degree elbow. And this is a 90-degree turn here, so it's called 90-degree elbow. And if it is an elbow, but it also again connects two pipes of different sizes. Then it's called a reduced elbow. Here you can see this is a much smaller pipe, where this is a much larger pipe. So this is reduced elbow. Then you have this, which is called as bell or hub. So this happens when the female pipe, the lower end of the female pipe is widened so that the male pipe can fit into it. So you can see this portion of the female pipe is widened so that a male pipe can fit into it. Okay, and that's called as bell or hub. Then you have this. This is called as T, as in the shape of a T. And so if you rotate it, you can see it's in the form of a T. This is double T or cross. And in double T or cross, usually you'll have one inlet and three outlet, or vice versa, which means you'll have one outlet and three inlet. So it can either be this or either be that. And usually the cross or double T are used in your sprinkler system. Then you have this, which is your Y junction. It's also called as Y junction, or else it's written as WYE, and it's also called as single equal junction. And this pipe is connected at 45 degrees. This is double Y junction or double equal junction. Where again the pipes are at connected at 45 degrees. Then we have something called as cap and plug. So this is cap, this is plug, and cap has female threads in it, while plug has male threads. This is covers over the pipe on top of it, while plug is used inside the pipe. And as you can see, this looks like a cap. The plug looks like a screw or a solid stopper kind of structure. Then you have union. So this is union. So union has basically three parts, but it also does look like a socket or a nipple. But the main thing is that it can be easily disconnected. And your union consists of three parts. It has the screw, it has the female part, and the male part. Sometimes it can be female and screw. Sometimes it can be male and screw. Anything can be union, but the main purpose of using union is that it can be easily disconnected. Appurtenance. So appurtenance are basically auxiliary fixtures that are added to the water supply or drainage system. For the control, regulation, maintenance of the system, and those auxiliary fixtures are called appurtenants, and these can be your valves or the flow control devices. All those are your appurtenants. Now let's move on to valves. So the valves can be divided into three categories depending upon the function of it. But in basic sense, valve is something that is either used to stop or allow the flow of liquid or water in our plumbing. So it can be divided into three categories depending upon the function. So it is isolation, you have throttling, and non-return. So isolation is your basic on or off. So it either kind of stops the flow of water or lets it go on. So that is your isolation. Then throttling is the control of flow of water, the pressure of it. All those are throttling. So this is regulates the flow and pressure of water. And non-return, as the name suggests, is basically means that water can flow only in one direction, it cannot return back to it. So in this, water flows in only one direction. And there are different varieties of valves, and let's look at few now. So you have sluice valve, which are used in your dams, municipality, etc. Then you have gate valves, which are used in industrial areas, all those places. Float or ball valves, 90-degree turn means full stop. Like you don't need to have to go on to rotate it. So a 90-degree turn of the valve means full stop or full on. Okay. And these all are your isolation valve. Then we have needle valve, where the name you get it because the stop or the flow regulator is basically in the shape of a needle. Bypass valve, and bypass valve was used to only for smaller flows. Then we have globe valve, which is the most common type of valve. Then there is stopcock or angle cock. Angle cock again means 90 degrees, means a full stop or a full on. And if you see here, your needle valve is a throttling valve. Is a throttling valve. Your globe valve is also again a throttling valve. Stop valve is an isolation valve, and so is your angle cock. There is another type of throttling valve called as the butterfly valve. Now, let's talk about some other valves as well. There is something called as pressure relief valve. So in pressure relief valve, it is all normally it's off. Okay, then when the pressure of the water is too high, it automatically turns on and lets out the excess water out. So that is your pressure relief valve. So this is normally closed. When pressure is high, this automatically opens and lets out the excess water. Lets out water to maintain the pressure. Then there is pressure reducing valve, which regulates the pressure. Okay, and then non-return or reflex or check valve. And as the name suggests, it means water can flow only in one direction. Cannot come back. And in the starting, we talked about something called as the hydropneumatic system, right? So there they use the pressure relief valve and the non-return valve. And these non-return valves are also used at the end of the drainage pipe. Like when your drain is connected with the municipal sewer lines, there you use this non-return valve so that the drainage from the sewer line does not flow back into the building. So, and the most common type of non-return valve that they use in the drainage fixture place is your flap valve. Then there is something called as air valve. Air valve or nothing but this automatically turns on when there is excess air. So to in order to let it out, it turns on automatically and removes the excess air from it. And it also permits air when the pipe is being emptied, releases the accumulated air out, or lets in when the pipe is being emptied. There is your fixture stop valve, which basically means that the water flow to that fixture alone is cut off. Fixture shut off valve, where the water flow to that fixture alone is cut off. And we are done with water supply and plumbing.